Okay, so here's the third and final video for this lab. I had to go do a Zoom meeting for your class, so that's why I kind of let this sit. So I've already added the sulfuric acid. Let me find where I am. I've added sulfuric acid, so now the product is the top layer. I have already added a few drops of the lower layer to a test tube to see if it was water soluble, and it is. So that's the lower label is the H2SO4. So I'm going to separate the bottom layer out, and then I can dilute it and flush it down the drain, and I will have the bromobutane still in my separatory funnel. So let me drain it. I'm going to take the lid off, see what you can see here. And I'm draining the bottom layer. Which is the sulfuric acid. My sulfuric acid is a little bit yellowy. It's not good because it's concentrated. I'm going to do it down a little bit lower so you can see it a little bit better. There we go. I want to have two hands to be able to do this. So I'm going to make sure that it drips and I get all of the sulfuric acid out. All right, so now I have bromobutane in there still. And the last step for this says separate the layers, allow 5 to 10 minutes for further drainage. I've been over an hour letting it drain, so I've let it drain long. And now I'm going to add 20 milliliters of 3 molar sodium hydroxide. Now, what is the sodium hydroxide going to do? It's water soluble, it's water based, but it's also going to hopefully remove the sulfuric acid. So it'll react with the sulfuric acid, whatever's left still in there. So 3 molar sodium hydroxide, where is it? There we go. Oops, it's back. There we go, 3 molar, about 20 milliliters. This doesn't have to be exact, just approximate. So I'm going to pour it into my flask, separatory funnel. I'm going to put the lid on it if I can find the lid. Here it is. Going to mix it. That's a nice little burp. Mix it a few more times. So I think that's the reaction of the sulfuric acid and the sodium hydroxide. Of course, sodium hydroxide is in the water layer. Kind of see the bubbles if you get in close. Let's see how close we can get. It's really hard to see. It is starting to separate out. Get that setting again. So we've added the sodium hydroxide. Now the density of the sodium hydroxide is a little bit more than water, 1.11 grams per liter. So the bromobutane is the bottom layer. So we've removed traces of acid. We're going to take the lower layer into an Erlenmeyer flask. We'll double check the top layer to make sure that that it's the water layer, but we're going to drain. Let me get another Erlenmeyer flask. All right, it's separated, and I'm going to drain out the lower layer, which is the bromobutane. And I can tell I don't have tons of it because I've spilled some of it along the way. All right, I let that go a little too fast. It's got a lot of water in it. I'm actually going to pour it back in and try it one more time. I'm actually going to get a clean flask. All right, one more time. We're going to do one more step to try to get the water out. So all right, so I've got my bromobutane out. The top here is the sodium hydroxide, but let's just double check. So here's my bromobutane is in my flask. And let's just I don't know what that is. I'll put a little bit of, let's see. Drain some of it and add some water to it. When I add water, it mixes, and so definitely I have the aqueous layer is still in the funnel. I'm going to actually mix it in with the sulfuric acid to help dilute it. Ooh, that really reacted. It says to put the sulfuric acid on ice and dilute it really well and put it down the drain. So I started to dilute it down with the NaOH. All right, so now we are at, it's a little bit cloudy, hard to tell. It's a little bit cloudy. What that means is there's still a little bit of water in there. Let's see if I can get the camera right. So this is lots of fun. I think I should go into cinematography here. All right, there's still a little bit of water in there. So what I'm going to do is I'm going to add a little bit of calcium chloride, which is anhydrous. It's actually some pellets. So it's really good at absorbing water. So I'm going to pour some of it into my container. And when I do that, what happens is it will pull the water into the sodium chloride and kind of dry out the bromobutane. So it's pulling the water out of it. It's not good because I do not have a very good, not have a good yield here since I spilled some of it. All right, let me pause it right here. All right, so I'm going to decant the bromobutane into a flask. It's much clearer now than it was because all the water has been left behind in the calcium chloride. I don't have very much, although I only started with 10 mils of bromobutane, or it's like butanol. Sorry, only started with 10 milliliters, so I might not be too bad. So I've decanted it into a 50 ml flask. Got to add another boiling stone. No, that's not it. That's the calcium chloride. Okay, I added the boiling stone, and now I am going to do a final distillation. So this, see if you can see what I'm doing. I don't know what you can see, but I've put my 50 ml flask here. I am going to put that down into the heater. I've reassembled my distillation. I've got it here. I am going to collect. I'm going to collect it. Distill the material boiling in the 99 to 103 degree range. So what I'm going to do is I'm going to get it, I'll catch it in a little beaker. So let me find that. All right, so what I did is let me move some of this out of the way. I got a little bottle, you can see right here. It's a little bottle that I weighed. And I have turned on my, I've got my, let's turn the camera up just a little bit. So I've got everything set up for a simple distillation. So my one last simple distillation to purify my bromobutane. It's going to take a few minutes for it to heat up. But what I did is I weighed this bottle, so all of my distillate is going to end up in the bottle, and then I'll reweigh it, and then I'll know how much I have gotten, how much has come out. So right now the temperature is still at room temperature, so I'll watch it, and when it gets to where it's dropping, I'll come back. Okay, so the reaction is starting to boil. I just got my first drop into my container. The temperature at that first drop is 93 degrees. The temperature is rising as I collect my sample. It says to collect the material boiling between 99 and 103. So, well, it started at 93, but that's close enough, I think. So I'll stop when it gets to 103, which it's not, it's only at 95 right now. All right, so the temperature has gotten up to about 99 degrees. I pretty much ran out of my sample, so I'm stopping the distillation. I'm going to let it drip a little bit more, and then I'll weigh it. Okay, so I've reweighed this once the sample was in my container. Here are the values. The flask and the sample together weighed 19.727 grams, and the empty flask 13.291 grams. So you can figure out what the mass of my sample was, what the mass of the product was, and I'll leave it to you to calculate the theoretical yield. So remember, we started with 10 milliliters of butanol. So 10 milliliters, you'll have to find the density to find out how many grams 10 milliliters is, and then convert that to moles, and then use the equation to find the moles of bromobutane. And then from moles of bromobutane, you can figure out the grams of bromobutane. So that will be your theoretical yield. Whoops. Sorry about that. And then you can use it to find the percent yield, which will be the amount, the actual divided by theoretical. So you should be able to figure that out from this data. So there's one other thing that I've got to do, and I'm going to check the, let's see, I'm going to check Now, obviously, it says a typical student yield is in the 10 to 12 gram range, so I'm not even close to that. So I've obviously spilled some somewhere, and definitely that's something you want to discuss in the conclusion, where else product might have been lost. So finally, we're going to measure the refractive index of the product to confirm its identity. So I'm going to pause this, set up the refractive index, and let you know about that, and then we'll be done. Okay, so the very last thing you can see here in the camera is the refractive index. So I've put the sample, I put the sample in there. It keeps falling down. If you remember from the last time I did this, this thing opens. You put your sample down in there, you close it up, put the light up, and then look into this. It's hard to explain, but actually I need to put a few more drops on there because it's dried off. So I need to move there's a black line in there that I know you can't see it, but there's a black line. It's bright above it and dark below it, and I get that centered, and then I can read the so the refractive index that I found. Let me get my paper here and write it for you. All right, so the refractive index that I found was 1.4375. So as I'm looking at this, it says that the bromobutane has a refractive index of 1.4392 to 1.4400. So mine's a little bit lower than that, and it kind of makes sense. What I didn't tell you earlier was that the temperature range for the boiling point range was 93. That was the first drop, up to about 99 degrees. I think I might have said that, but I can't remember. So it's a little bit lower than what was expected, up to about 101 for bromobutane. So I suspect that I probably have a little bit of still contamination with water or something like that, which is kind of weird because I have such a low yield. But anyway, the fact that the refractive index is pretty darn close, so it's just a little bit lower than what it should be. So I think we can be pretty confident that we have the bromobutane. It's probably just a little bit more contaminated than it should be. But anyway, all in all, successful lab. We did get some product. You can calculate the theoretical yield, and you can discuss identifying it with the refractive index and the boiling point. So again, the boiling point could be a little lower because of the atmospheric pressure, but it also could be a little lower due to contamination. So anyway, thanks again, and I hope I'll talk to you soon. Bye.